Rush. Okay, just as we get going again, let me go ahead and just confirm kind of what we did over the break, just so you know. So back over in the model, we went through, and I actually was sort of intrigued by Henry's question about really, why do we reverse and does it make any difference? So I took that out. Yeah, just kind of flattening completely and going straight to the grids. And you can see that, at least in terms of the panels that we're working with right now, it doesn't make any difference. Okay, I think that what we're going to find if we had a panel that had some directionality to it is that, as opposed to paneling, for example, in the lower left-hand corner all the way to the upper right-hand corner, we're probably paneling from the upper right-hand corner down to the lower left. So just the order of like 1, 2, 3, 4, those 4 different points is probably reversed. And if there was a directionality, you'd sort of see some sort of rotation in the panels. But for these panels, it doesn't really make much of a difference, but that's something for us to go ahead and experiment with to kind of really get that answer to, just exactly how things flipped. And then we get into whole flipping vertically and horizontally and all that kind of stuff, depending on what directionality we want the panels to have. That'd be another good function to kind of write in terms of what we want to do. Okay, so let us go back and just kind of take stock of where we are so far. We've divided this thing into ribs. We've gone ahead and applied these adaptive panels. We divided the panels between the ribs to give us more control. So we're actually in pretty good shape. What I want to do now is to actually just go through and do just a little kind of playing around with the whole notion of, we had that whole thing about the sun and the coloration that we could use from the sun, or even resizing the openings based on the sun. And that example really came originally out of the stadium. So let me go ahead and kind of show you how we can apply it and actually use custom nodes to kind of make some of our work a little bit easier relative to doing that. Okay, so let me go back on over and looking at either step 12 or step 13, kind of show you how we can try to incorporate those sort of features, but do it in a way that's pretty easy. Okay, so I'm going to go just open step 12. Which should look amazingly similar in some way. The big difference that we're going to go through and kind of like to introduce, it's doing a little regeneration here, is we're going to go through and actually do some changing of the opening size based on some notion of the sun's directness. Hang on, so it's just regenerating again, and I'll apologize that it's taking some while for it to do that. But what we're going to do is actually harken back to something we did several sessions ago, where based on the whole notion of the sun path and trying to look at some vectors between each of the different panels, the best fit plane for each of the different panels, and the sun, we'd go through and just measure some what we considered a distance, relative to the sun. And let's see if we can. It's still regenerating. I thought it was done there for just a second. It looks like it's trying. Okay. It's finally done? Not quite. Apologize it's taken so long. But as we're waiting for that, let me see if I can talk you through this. So in the Dynamo window, you can see we're actually going to be grabbing the sun path direction. There we go, finally. Phew. Okay. Zoom that back out. I'm hoping there's not two sets of panels on top of there. There may be, but we'll take a look at it in a second. Okay, so here's the idea. We're going to grab the sun path location. Okay, we want to go through and ultimately, based on some sort of directness value, scale that, okay, and use it to set the opening parameter. And we did this to this other surface, the kind of simple surface that just kind of folded over that we ultimately ended up putting our picture on too. But it's the same basic logic. So we can go back to, I think it's in session 7, and kind of take a look at all that different logic. But let's talk about how you can implement some of these things a little more easily. Because the idea is, we did that hard work in terms of setting that up once. We'd really like to be able to go through and reuse that fairly easily. So here's what we're going to do. So really, there's this whole notion of how, given a sun's path, I can go through and get some sort of relative listing of, for a bunch of different quads, how directly those quads or the best fit plane face the sun, just some sort of scaling. Okay? And in terms of trying to think about that, if I had a function, or I wanted to define a function like that I could use in any scenario, I'm going to use it here in this scenario, but I could just as easily, use that same sort of node, that same sort of custom function in a bunch of different scenarios. The good thing to do is to try to create a custom node. And again, where you do that is under the file, you can say new, create a custom node. Okay, I've already created one. You can sort of tell because it has that little box hanging around it. I'm going to say just edit that one. And you'll see actually how that thing's defined. So this logic may look a little bit familiar to you. It has a couple of different inputs, the sun path. So one thing we're going to drag into the custom node is the sun path. We're also going to feed it a list of quads. Okay, and then this whole logic in here of creating a best fit plane, kind of taking the normal, the origin points, and computing the distance between those two, flattening that list and sorting it so I can get the first and the last of the list, then computing some sort of scale. So this is interpolating between any x value and really where it is in that range, so I can just sort of normalize them all to kind of get myself somewhere between 0 and 1. And finally, I'm just going to output this thing called directness value. Okay? And really, that whole node, okay, is really something that's going to be incredibly useful to us. So that node, okay, shows up here, looking like this. This has the two different inputs. It has this directness value coming out. Okay, and then from that, we're just going to divide that by 2 to scale it and set the openings kind of based on that. So the point here is really just about custom nodes and using custom nodes and sharing custom nodes. So I've gone through and created this custom node. You'll see that if you edit its properties, it's this whole thing about getting it to kind of appear in the list. Really what we're kind of doing is goosing it along. Okay, and then it will show up down in the list with, as one of the nodes that we have available. I sort of put it, returns a value of 0 to 1 based on the rotation relative to the sun's path. So this, I just defined, and you can do something just as easily yourself. Okay, as you go through and define these nodes, what you can do is actually just stash them away. Just so you know where they're all hanging out is in that same session 10 folder. Like Parametric Stadium. Okay, they should be in the same folder. If they're not installed in the core, in the root of kind of your Dynamo installation, make sure they're in the same folder as the other Dynamo scripts that are depending on them. So you'll see I've defined something called evaluate some directness. It's a DYF as opposed to a DYN, so it's understood as being something a little bit less than a complete environment. So I defined one, which is really all about just evaluating the sun's directness. You'll see I've actually created another one, which is really all about mapping those values to the color range blue to red. So again, there's nothing new here. Those are things that we did, I think, in section 7 and 7 and 8, maybe. I think probably mostly in 7. But, we can go through and compartmentalize and reuse those things and make it available other places. So the idea here is if I say, let's evaluate the sun's directness, okay, grab a bunch of different values in here, and you'll see it returns a list of values 0 to 1. I can scale that down just by a factor of 2 because the opening parameter just expects a value between 0 and 0.5, and then set that parameter. Okay. Now, just to avoid having to regenerate that panel geometry every time, I'm going to say, no, actually I do need to keep it turned on. I take that back, because in order to go through and set the properties, I saw that it kind of went red, so that was not going to work. So if I am ready to run, actually looks like I'm running automatically. You'll see that what's happening now is all the different panels are responding to the notion of the sun path. Actually, let's see if the sun path even sort of shows in right now. It says no sun path registered. We need to go through and do that. So back over here in Revit, I'm going to turn on the sun path. I can control the sun path. So whether I want it to be the summer solstice or the winter solstice. Notice that the summer solstice, basically the sun's high in the sky. All the panels at the top of the stadium are relatively closed. These ones on the outside are relatively open because the sun's not facing them very directly. Whereas if I change that around to the winter solstice or something like that, or the winter at a specific time, at 10 a.m. or 8 a.m. or whatever it is I want to do, we're going to have a different sort of distribution. Okay, let's go back to Dynamo. Actually, since it's evaluating automatically, okay, let me register the sun's path. It'll pull those values. Then we should start seeing some change. I'm going to turn off run automatically. See what's happening down here. Looks like it hasn't actually kind of picked it up. I'll turn the run automatically back on. Either that or it's still computing. Zoom on out. Try moving that sun path over here, for example. Oh, let's make it 5 p.m. Okay, that has changed. Let's see if we can actually get the, it's already open. It's just going to hang around down here. They run automatically. trying to get it to respond. It looks like it's being a little hesitant, and I don't know if that's just the number or the the whole issue of the number of points, and it's just sort of catching up with me. I think it is still just computing in the background. I'm just trying to introduce enough of a change that you'll actually see the difference. In terms of the behavior. Because it looks like we're not seeing enough of the impact that I'd like to see in there. But I think it's just a refresh thing in terms of what's going on. Okay, let me kind of add the other one in here and see if we can make it that visible to you. Because it's all still look pretty uniform right in there. I think that's just a Revit updating thing. Or hang on. Let me check something here. My suspicion, what I'm wondering about is if I actually have two different sets of panels on top of each other, which would sort of confound things a little bit. Yes, I do. Okay, can you tell? What I'm doing is I'm deleting the other panels. So you're not seeing the change panels underneath these panels, which of course is kind of really confounding matters. Okay, that sort of makes me a little happier in terms of why we're not seeing the impact, because we should be seeing the impact in terms of the panels. So let me go ahead and fix that, and we'll run that. Actually, what I'll do is I'll go open up the next piece of the example, the one that adds the color in there too, and you'll sort of get it all at once. Because we might as well just go ahead and do them both at the same time. Because it really is the same basic operation. We're just going to use those two different values to do two different things, one of which is to generate the panel openings, the other is to set the color. What's happening is since I took out some of the panels, now it's going to go through and try to regenerate them all again. Which of course is just taking up time. Turn off that, just so we can avoid that. Okay, let me go back over to open. And I'm going to open up the one that includes the color too. Then we'll clear out our workplace and kind of make them both happen at once. Okay, one function was the set sun directness. That's just going to return this value 0 to 1. The other function that we're going to build is something called mapping the values to colors, blue to red. And if you want to take a look at that, this is again something that we just did in class. I think it was in session 7, where I can edit that custom node and see that there's two different values. I have a value which is pure blue, and I have a value which is pure red. And I'm just going to, based on some input values, just kind of map things in anywhere from blue to red. So the higher the value, the closer to 1, the more red it is. And at the tail end of that, output's going to come just a stream of RGB colors. Okay, so again, this is just based on kind of what we did in class, just set up as a custom node. Come over here. If I want to make that available to you. You can just grab it and kind of use it because it's in the same folder. If I want to put it in my little browser, I just need to say edit its properties and it'll put it in there. Or if you want to sort of put this out on the open market and let other people share it, you can sort of publish these as a package and kind of put it out there in the packages that people can search for. You can publish these nodes. Yeah, just make them available. Kind of like putting things in Revit City. Okay, so to run all this, let me do this just to kind of clean this up, just so you can actually see what the impact is, since that's what was getting me in trouble last time. So I'm going to take all those out, say goodbye to all that. Okay, then we'll rerun the geometry. Even over here, for this script, say that we want to use the sun path from that view. Okay, beautiful. Shall we give it a run? Okay, and as it's working away back over there, let me kind of just flip over and see if there's any questions. Okay, so Henry's asking, I was wondering about the industry applications of this. So would we design a facility building with windows panels that automatically open and close at different times of day, days of the year, according to the information from combo? Actually, potentially. So Henry, it's kind of interesting because, we could go ahead and model to try and understand, which sort of panels are going to be the most useful ones that could be affected by some sort of dynamic behavior. Chances are, though, we would actually go through and it could be using the model behavior that's predicted, set things to how we think they will be. We'll probably actually use some real-time sensoring, something that actually is to precisely measuring what the sunlight values are, what the insulation values are, and then adapt those panels in real time. So I'd view this sort of modeling as being a good predictive tool, for understanding which sort of things you're going to get the biggest benefit out of kind of making them adaptive. And then from that, saying that you can either continue to use the model to help, predict behavior, but it's always, influenced or enhanced by what you're measuring in real time. So a very, very good question about really what the application of this is. And I think that, there's several folks I've talked to who are interested in the whole notion of dynamic buildings, living buildings, having things respond to the environment. And that's what this is really all about. So very good question. Okay, let's see if we finished up over here. Looks like we actually did. Although it's interesting, it looks like there's still some other elements kind of hanging around in here. Either that or it's just the purple. Hang on, let me see what this is doing. That's the shadow. I can turn that on and off. Just put it on a consistent color so you can sort of see the effect better. What you're starting to see now is that in the locations where the sun's hitting the most directly, okay, the panel openings are small and those panels are red. The blue panels are more open. Those are the ones that are not getting very much solar radiation at all, at least at this specific time of the day. This is where the sun's happening and be hitting the most directly right now. So how could we use this? It's really, if we have some shades inside the building, if we have some apertures that can open or close, if we have some sort of a phase change material that could change its opacity, things like that, to go ahead and respond to this stuff. So that is the stadium example. And, I hope we sort of illustrated that you can go ahead and generate a lot of very useful Revit geometry, just really doing it parametrically. I haven't really placed any kind of standard Revit elements, but been able to generate an awful lot of the initial form. And from here, they are Revit elements. I can go through and kind of continue to adapt and change and, kind of place things in a more standard way. Okay, so let us pause there for a second and go through and really start introducing the next topic. And we'll do this kind of stepwise because we have about 10 more minutes left today. But let me go ahead and demonstrate something about optimization and how it can be used. And from that, we'll go ahead and kind of think about how we're going to use it. Okay, because we're going to get to this point where we would like to go through and not only sort of create geometry, we'd like to be able to get answers from the Revit model, so that we know a little bit about, just things that could only be computed by really evaluating the model. And we could look at things that are sort of, energy-related things, solar-related things. We could look at temperature-related things, anything about fluid and winds. There's a lot of different things we can measure from the model where the answers aren't as simple as just adding 1 plus 2 plus 3 or x plus y plus z, but we actually need the model to go through and do some calculation for us. Can use the analysis tools that are available there. So could be doing structural analysis, could be doing just a lot of different types of analysis, but we're basically pulling data and getting answers from models. Okay, so let me kind of give you an illustration of that, and I'll use something called the solar radiation optimizer, and then next time we'll go ahead and build something like that together, which does our own little bit of optimization and sets up some control loops to iterate through some options and evaluate the model at each of those different options. Okay, so here's how we're going to approach that. Let me go back over to, and it is example 10.2 if you want to follow along, but it's not actually a Revit example. It's a Vasari example. So if you don't have Vasari loaded on your machine, not to worry. I'm going to load it up and kind of demonstrate it here. If you do, you can follow along and kind of run it. If not, we're going to do the same things in Revit, on Thursday. So let's just go ahead and kind of show you how this works. So in example 10.2, if you go out and open that, you'll see we have a little sample city set up. Now I'm going to use Vasari because Vasari has a really good solar radiation calculation tool in it, and that's what we're going to try and evaluate here. So here's the basic scenario. We've got this little building. It's kind of sitting in a cityscape. We want to try and basically optimize the directionality or the orientation of this building relative to the other things in the city to kind of maximize the sun that we can actually get on that roof. So let's set it up just in terms of what we want to do. In terms of analyzing, we're going to use some solar radiation analysis. And what I'm going to do is say that what we're going to do is take a look at this surface right here. Okay, finish that up. It'll go through and do some calculations. That's the solar radiation, kind of cumulative solar radiation. Let me go ahead and say that I want to do a little output or export. I'm going to put that thing just on my desktop, just to kind of make it easy for me. Solar radiation, I'll call it 6, because it's the 6th today. Okay, it's going to put those values out there. And I can just say automatically update that. Okay, beautiful. What's going to happen is if I go through and change things, it's going to write a series of different values out there, and it'll continue to update them as we change things. So if I go through and use Dynamo with this, let me show you what you can actually do. Open. Again, session 10. We got a little script set up here. It's actually quite a complicated script, so I'll encourage you to dig in at some point, but don't worry about it just yet. Basically, what this is going to do is go through and take a family instance, that is this parametric building. It's going to increment all the way from 1 to 36, 10 degrees at a time. So it's basically going to rotate around 360. And as it rotates 360, it's going to try to figure out really what the best orientation is for maximizing the solar radiation. Put it over there so we can see it a little bit better. Okay, I need to basically tell it where to store the files, the data, as it works. So I'm going to go out to my desktop. And this is where it's going to be looking for the data values. Solar radiation 6. Say okay. Great. We are ready to run. Let me show you what it does. And we'll talk you through. And this is where we'll finish today. What it's doing is it's just taking that building and rotating it 10 degrees at a time through 36 different increments. And as it looks at each of those different 36 different potential orientations, it's using the solar radiation tool to calculate just really how much solar radiation I can capture on that roof surface. So we're going to look at 36 different options. We're going to do a kind of complex calculation for each of those 36 different options. Okay, and based on all 36 of those different options, it's basically going to say this orientation, this was the maximum value. Okay, that gave us the best characteristics for what we wanted to do. And just as a preview, that's where we're going to be going next. It's really this whole notion: can we go through and really use Revit or Vasari to do complex calculations? So not just simple formulas that we relate together, but actually use the computational architecture behind there to compute areas and volumes and analysis results based on the model, whereas we tweak different input parameters to the model. We return those values and then use some sort of a control scheme to either loop through a simple system or to go tunneling down and try to target the ones that we think are the best. Okay, and let's just go ahead and stop for there because it's going to just start the whole next discussion, but just really save that for next time. Okay, so any questions as we adjourn? And when we get back together on Thursday, that's where we're going to pick it up.